Hello everyone, this is JD from Engine Squared. Today we're going to be doing a tutorial on how to do multi-robot gripping simulation with realvirtual in Unity, driven by RoboDK. So we're going to start off with a basic scene here. One robot, kinematics defined, linked to RoboDK. So we can see over here that it's linked to my active RoboDK file. I'm going to go ahead and rename the robot. So as you can see here, we're going to hit the play button. And right now, we just got this, all we can really do is jog it and teach it. So we're going to turn this into being able to grip an object. So let's move it back to the home position. Get back into editor. Before starting this tutorial, you should have kinematics defined in your robot as shown over here. You don't really need a gripper to do this, so I have an end of arm tool here, which is the basic vacuum gripper. So over here, under A6 or J6, whatever your convention is, you can put either a kinematic gripper or a static gripper, such as something like a vacuum cup. And you got to make what I call here the pick zone. So the pick zone is really just cube mesh. So I've turned off the mesh renderer in Unity. When I turn it on, you can see it's just a transparent zone that gives a signal to be able to pick an object. So you can see here I have this sensor script attached. By default, when a material is occupied, it goes red. When it's not occupied, it's yellow. Under the grip script, it's important to have the pick zone dragged in over here. So let's just do this from scratch to show you how it works. So under A6, it can be anywhere. In this case, we're going to put it under the end of arm tool game object. We're going to create a 3D object cube. So we're going to move that over here. Then we're going to scale it down. Like this. Then position it roughly where the part to be gripped, which we'll create a model for later, is going to be placed. Just center this a little bit. And there we go. So now we have our, let's call this pick zone. So we're going to go ahead and add sensor script. Now you can see by default it's on the material not occupied color. We're going to add grip script over here. So now you can see both those scripts are attached to this pick zone game object that we just created. Then we're going to take that same pick zone parent object and put it under part to grip. So basically it's like, in terms of the software, it's like gripping itself. I'm going to go ahead and save. Make sure you save at every stage that you make progress. So now let's create object to be gripped. So let's also go with a cube here. We can place it. Let's make it smaller. Let's make it a bit bigger, yeah. Let's rename it part. And we'll place it somewhere over here. Just temporary. Then let's go ahead and copy paste the robot. I'm going to make this R2. I'm going to change the robot name in the RoboDK Interface script. Then we're going to move it, let's say 1.5 meters. Oops. Let's go with 1 meter in the negative Z direction. Then let's do this as well on RoboDK. So we'll copy, drag in another robot. Let's rename it. Let's deactivate the active reference frame. And then you see here, in terms of position, if you make this 0, it goes back to the same spot. So make it 1,000 millimeters. So by default, RoboDK is in millimeters, and Unity is in meters by default. So it looks like they're a bit further than each other. Okay, so this robot is 1 meter in the Z direction. So let's move this one 2 meters. So they're 2 meters apart. So we're going to go ahead and save both RoboDK and Unity. Then on the part here, we're going to add, so we have a box collider. Let's make this rigid body. Yeah, we'll keep this on for now. Use gravity. And we'll set this to, set these parameters here. Often, if you have any issues related to parts not being gripped correctly, it's usually to do with the box collider and the type of mesh you're using on the part, so keep that in mind. Yeah, in this tutorial, we're just going to do a rough simulation, you know, but for real projects, you got to make sure your references are accurate, so the system behaves as a real digital twin. This is just for tutorial purposes only. So over here we have a ground object that I've just made as a box collider. So it's Yeah, it's under the surface here. You need a ground object with a static option here enabled. So this makes it so your part being gripped can sit on that object and not fall down. So the best way to get the grip function working is to split it into small steps. So over here, we're going to test what we have so far. So you can see both robots are successfully linked to RoboDK. Both of them will move when jogged. So you see this one moving too. So we're going to go ahead and test and see if this box collider is triggering the sensor. So if we go down here, you can see that once the sensor is clashing with the part to be picked up, it turns red. So this is an indication that it's working correctly. You can see when you lift it up, it goes back to yellow. So this is exactly the progress that we want. If you don't have this at this stage, then you're doing something incorrect, most likely. Or if you don't have this at this stage, then it could be a possibility that there's a step missing in the process. So try to go back from here to see what's wrong. And if you're stuck at this stage, feel free to throw a comment, and we can definitely help out. So one thing I learned in this test is that this material, this part to be gripped, is a bit too far. So we're going to move it back a little bit. So we'll go ahead again and see. Yeah, this is much better. And you notice when the part, it's initially off the ground a little bit, and it stops and hits the ground. So this is exactly how we want it to behave. So we'll go ahead and move to the next step of the tutorial, which is creating some signal IOs to signal the actual picking and placing of the part. So we're going to go ahead and right-click on the first robot and create some empty game objects. We're going to do this for the second robot as well. We're going to rename those game objects is at pick 1, is at place 1, and then same thing for the other robot, but with 2 instead of 1 on the end. So now we've created those game objects, and time to make them signals. So we're going to make PLC output bools. So now that we've created these PLC output bools, we're going to create some variables in RoboDK as well. Actually first let's do some teaching in RoboDK before we go ahead with that. So you can see here, because we created those global variable IOs and they're not defined in RoboDK, the robot will not move. So let's go back and just disable them for now using this checkbox here in Unity. Then when you go back to RoboDK, you can see that the robot has moved a little bit since our last jog, so now we got them moving. So we'll go back to the home position. Then actually, another thing I'm going to do is reposition this part so that the robot avoids a singularity. So we'll get some action from A4 and A5. This way we'll avoid a singularity. So I'll put that part right there. Go back and hit the play button. You want a tutorial on singularities and how to avoid them, let me know in the comments. So typically in factories, you don't use, on a shop floor, you don't use the factory robot home position as a home position for the robot. So in this case, we're going to create our own home position. So we're going to teach this current position. Then we're going to rename it. Then using that reference, let's just go a little bit above that position. So this way we get a nice position there to reference a linear motion from. So I can see it's a little bit off center, so let's move the robot somewhere here. We can move this over here. And we know this is pick R1. So we can copy the Y position to the approach, and it'll shift right there. So now testing these targets, we can see that they're behaving correctly, both RoboDK and Unity. So now it's time to create a program in RoboDK for this robot and see where we're going to place the part. So we'll go ahead and click the robot. And the targets. And then create program button should automatically create a program that works as we intend. that pick R1 equals false. We're going to copy this, change it to is at place R1 is false. So we're going to go back to home, then we're going to go to approach. So we're going to make this a joint move. So just make sure it's behaving correctly here. So yeah, I'm okay with this. We're going to copy that previous pick IO that we created, or pick output, place it over here. Now we're going to set it equal to true. Actually, we're going to do that over here. Yeah, right after the pick linear move. So then, once it's at this position, the next task is to pick the part. So we'll go ahead and copy the approach again. And then we're going to create a new area for it to pass the part over to the other robot. So we're going to teach the current position. We're going to rename this move 1. Then we're going to rotate it as so, just for simplicity. Center it a little bit more. We're going to teach this position. We're going to call it pass 1. So now if we go back and jog the robot through the program, we're going to go for the approach. We're going to go for the pick. So we currently have our IOs disabled. We can enable them here, and then execute instruction on the false, and then execute instruction on the true. It seems like it's not working here, so we gotta go back to the editor. So just in case, let's save. I'm going to go ahead and enable these. So if you follow the instructions and it seems still not be working, as shown over here, the robot's jogging, it's not moving in Unity. There's most likely some sort of an error, usually in consistency between the two software. So in this case, we have is at pick R1, and then we have is at pick 1 in Unity. So we got to make these consistent. So we're going to hit the play button again, and now everything should be working fine. So you can see here, we're going to go for the approach. We're going to move to the pick. We're going to execute the false for the pick, and then execute the true. So you can see here, it triggered the output from RoboDK, it's true, but it didn't pick the part. So we still have one missing step. So we're going to go ahead and set this back to false. So we're going to go back to the pick zone. I'm going to do this for both robots. It's better in the future to configure this for one robot, so you're not doing it twice. So the parts we have missing are the PLC IOs for signaling pick and place. So we're going to take the outputs we created and put them in their corresponding areas. So this global variable will be the pick for the sensor that we created, and this one will be the place. So we'll go ahead and do this for the second robot as well. So now if we hit the play button, we should be able to see some gripper action. So we're going to go for the approach. We're going to go for the pick. We're going to make sure pick is false, place is false. And then we're going to execute the instruction for pick. Now you can see that this is true. We have a message here saying no MU on object for gripping detected. So this is probably the reason why it's not working right now. So we'll go ahead and restart. Let's add an MU script. So this is a critical part that needs to be added so that realvirtual knows that this is a part that's going to be picked and doesn't go ahead and pick other parts. So we want to change the layer for this part to G4A SensorMU. Let's change this to G4A sensor for the layer. So now we should be in business. So we're going to go ahead and drive this from RoboDK. So we'll execute our false IOs, and then we'll execute the pick. You can see it's true over here now. So now you can see we've successfully picked up the box. We're going to go ahead and select our targets here, holding down Control, holding the robot program. We're going to add some joint moves. So we're going to execute move 1, and then we're going to execute what I called pass 1. So now we have the handoff position enabled. We're going to go ahead and teach some positions for robot 2. So we're going to deactivate the reference frame from robot 1, activate the reference frame for robot 2. And then we're going to create home position for robot 2. Somewhere right over here looks pretty good. So we're going to teach that. So now that we have the target for move 1 R2, we're going to go to pass 1 R2. So as you can see, we have an issue there with the collider that we got to fix like we did for the first robot, with the layers rather. So let's go ahead and just position it to start. So that's good enough for the purposes of this simulation. I teach this position. It's going to be pass 1. So I just got cut off there. Didn't realize I wasn't recording. So just going to review some of the steps here. To update the sensor layers and stuff that we did for R1, for R2, it's easier to just delete it and replace it. So we're going to go ahead and copy R1. We'll temporarily rename it R21, and we'll delete R2. But first, let's make sure we have the correct position. So it's -1 meter in the Z direction. So we're going to delete R2, and now we'll rename this R2. So now we have all the sensor layer settings that we did previously. We'll go ahead and rename the outputs, and our links are the same here. We just need to rename the robot name to R2. So one super important thing in Unity and Real Virtual is to know the composition of each game object you're dealing with, whether you should use a mesh collider or not, whether you should use a rigid body or not, whether you should use a physics material or not. Yeah, this is very important. We're going to go ahead and get this moving. So we're going to pick the part, we're going to move it, we're going to pass it. So now we're going to create a program for R2. So we're going to highlight all those components, click Create Program. As you can see, it's automatically generated trajectory. We're going to name this program, oh, too close to Singularity. Well, that's because it's a linear move, so we're going to fix that. Let's just take this back to the home position. So we're going to call this program R2 pick and place. So we're going to copy the variables from our previous program just to speed up the workflow. We're going to make sure these are renamed to R2. and we're going to confirm that they're the same thing in Unity in a little bit here. So yeah, I can see it's is at pick R2, so we should be okay there. So we're going to keep this pick as a linear move. Oh, this is R1. So home, we're going to keep it as a joint move. Move 1 is going to be a joint move, not a linear move. Approach is going to be a joint move. And then pass is going to remain as a linear move. So yeah, we just specified the program name here to make sure that it's going, that robot is being driven by a specific program. Trying to see what else could be potentially missing. Yeah, at this stage I don't really see anything, so let's give this a shot. So let's go ahead and let's pick up that first object. Then we'll brush this up a little bit as it starts to be a little more functional. This is the great thing about offline programming is, offline programming, offline motion planning. You basically do whatever you want, plan things out beforehand. Once you incorporate all the correct dimensions. So you can see here it's not perfectly positioned, but for the purposes of this tutorial, it's okay. Then for R2, it's going to be true. So we enabled the true, false for R1, so you can see the values changed here accordingly. So now, if we go back to the approach, you can see R2 is grabbing the part and R1 has let go. So we're going to go ahead and add some new motions here. So let's avoid that clash with the ground. So we're going to call this and teach this position and call it move to R2. And then we're going to rotate this a little bit. We're going to call this position move 3 R2. And then we're going to let go. So selecting those two targets and the R2 robot program, and then hitting the joint movement, we've created those motions. So then we're going to add, is that pick 2 equals false? So now if we execute this, nothing happens. So we need to enable the is at place to be true. So now if we execute this, the part gets dropped. So now let's return both our robots to the home positions, to their respective home positions. We're going to save both our RoboDK file and Unity file. I'm going to hit the play button and see how this has turned out from the start. So we're going to right click the R1 program. We're not going to loop it. We're just going to hit run. So you can see on its own, it's gone ahead and picked up the box, getting it into position for R2. And then we're going to run the R2 program. Which goes ahead and picks up the box and then drops it. So now I've brushed up a little bit of the positioning to make simulation look a bit cleaner. So we're going to go ahead and compile this into one program. So just as I've shown in a previous tutorial, we're going to create a program. I'm going to call it master. We're going to add some program calls. So we'll start a thread, select the first robot program, and select the second. So now it's going to call these in order. So these programs are in series. Once you get more advanced, and later on I'll show how to use IOs in a more complex way, to have programs running in parallel and talking with the conveyor and that sort of thing. So yeah, let's go ahead and give this a shot. So we have both robots starting here at the home position. So let's minimize this window here so we can see both side by side. We're going to right click the master program and run it. So it calls the first robot program and then calls the second one after that one's done. So yeah, if you enjoyed this tutorial, like and subscribe. Let us know what you're having trouble with, what you'd like to see. We'd be happy to help.